My name is Basir. In this video, I will be teaching you Chapter 6 Triangles from CBSE Grade 10 syllabus. Now, in your earlier classes, you must have already learned about triangles and their properties. In Grade 9, you learned about congruent triangles, isn't it? Now, what are congruent figures? Two figures are said to be congruent if they have the same shape and the same size. So two circles with the same radii are congruent to each other. Likewise, two squares with the same side length are congruent to each other because obviously they have the same shape and the same size. Now, congruent figures, when you place one congruent figure above the other, the two congruent figures cover each other completely because they have the same shape and the same size. Now, let us learn about similar figures. What are similar figures and how different are they from congruent figures? Two figures having the same shape and not necessarily the same size are called similar figures. So similar figures, they have the same shape but not necessarily the same size. So you can see here I have two squares here. Two squares, they have the same shape obviously because this is a square and this also is a square, but then they don't have the same size because the side length of this square is bigger than the side length of this square. So similar figures, they have the same shape but not necessarily the same size. Now can you tell if this quadrilateral ABCD and the quadrilateral PQRS, are these two quadrilaterals similar to each other? What are similar figures? Similar figures are figures which have the same shape but not the same size. Now, these two figures, it looks like they have the same shape, but then can I be sure that they are similar figures? I cannot be sure of that. So there has to be some rule using which I can verify that the two given figures are similar. So what's the rule? Two polygons having the same number of sides. Now I have two polygons here. Both these polygons are quadrilaterals. A quadrilateral is a polygon which has four sides. Obviously ABCD is a quadrilateral because it has four sides, and then obviously PQRS is also a quadrilateral because it also has four sides, PQ, QR, RS and SP. So two polygons having the same number of sides are similar to each other if the corresponding angles are equal and the corresponding sides are in the same ratio. What do you mean by that? The corresponding angles has to be equal, which means angle A should be equal to angle P. Similarly, angle D should be equal to angle S. Likewise, angle B should be equal to angle Q. In the same manner, angle C, that should be equal to angle R. So, the first rule is the corresponding angles have to be equal. And then the second rule says the corresponding sides should be in the same ratio, which means AB by PQ, that should be equal to BC by QR, that should be equal to DC by SR, that should be equal to AD by PS. For AB, the corresponding side is PQ. For BC, the corresponding side is QR. For DC, the corresponding side is SR. For AD, the corresponding side is PS. So obviously the ratio of the corresponding sides has to be same. So two polygons having the same number of sides are similar to each other if the corresponding angles are equal and the ratio of the corresponding sides is same. Let us now check if these two quadrilaterals are similar or not. I have a quadrilateral ABCD. The angles are given and the sides are given, and then I have another quadrilateral PQRS. The angles are given and the sides are given. Let us check if the corresponding angles are equal. Now you can see here, for angle D, the corresponding angle is angle S. I see that each of them is equal to 85 degrees. And then for angle C, the corresponding angle is angle R, and I see that each of them is equal to 70 degrees. For angle A, the corresponding angle is angle B, and I see that each of them is equal to 105 degrees. For angle B, the corresponding angle is angle Q, and I see that each of them is equal to 100 degrees. So I see that the corresponding angles are equal here. Let us now check if the corresponding sides are in the same ratio. For the side AD, the corresponding side is PS. For the side AB, the corresponding side is PQ. For the side BC, obviously the corresponding side is QR. For the side DC, the corresponding side is SR. So let us find out the ratio of the corresponding sides. So AD by BS, AB by PQ, BC by QR, and then DC by SR. We are finding the ratio of the corresponding sides. Now AD is how much? AD is 1.5, so I wrote AD is 2.1, so obviously I wrote 2.1 here, and then PS is 4.2, so I wrote 4.2 here. AB is 1.5, so I wrote 1.5 here. PQ is 3 centimeters, so I wrote 3 here. BC is 2.5, and then QR is 5, so I wrote 5 here. DC is 2.4, and then SR is 4.8. Now what happens? 2.1 and 4.2, they have the same number of decimal places, because after point you have one number here, after decimal point you have one number here also. So they have the same number of decimal places, so you can get rid of the decimal point. And once you get rid of the decimal point, you have 21 in the numerator, 42 in the denominator. 21 into 1 is 21, 21 into 2 is 42. So I'm getting the ratio of AD and PS as 1:2. 1 by 2, you can write it as 1:2. In the same manner, 1.5 into 1 is 1.5, 1.5 into 2 is 3. So here also I'm getting the ratio as 1:2. 2.5 into 1 is 2.5, 2.5 into 2 is 5. So here also I'm getting the ratio as 1:2. 2.4 and 4.8, they have the same number of decimal places, because after decimal point you have one number here, after decimal point you have one number here, the same number of decimal places. So I got rid of the decimal point. And then 24 into 1 is 24, 24 into 2 is 48. Again, I'm getting the ratio as 1:2. So what do we see here? We see that the two quadrilaterals ABCD and PQRS are similar to each other. Why? Because the corresponding angles are equal, and then the ratio of the corresponding sides is also same, because the ratio of corresponding sides is 1:2. It is same everywhere here. So since in these two quadrilaterals the corresponding angles are equal, and then the ratio of corresponding sides is also same, I can say that these two quadrilaterals are similar to each other. Now, can I say that these two quadrilaterals are similar to each other? This one, the first quadrilateral ABCD, it looks like a square to me, because obviously each of the sides is 5 centimeter here. But then the quadrilateral PQRS, it looks like a rectangle to me, because one of the parallel sides is little longer than the other two sides. So this looks like a rectangle. This is a square and this is a rectangle. They don't look similar to us. Why are they not similar? Because the ratio of corresponding sides is not same here. Let us find out the ratio of the corresponding sides. For the side AD, the corresponding side is PS. For the side BC, the corresponding side is QR. For the side AB, the corresponding side is PQ. For the side DC, the corresponding side is SR. So I found out the ratio here, and I see that the ratio is not same all the time. Here I'm getting, in these two cases I'm getting the ratio as 1:1, but then the other two cases I'm getting the ratio as 5:7. So the ratio of corresponding sides is not same here. So the two figures, the two quadrilaterals are not similar to each other. Even though the corresponding angles are equal, this angle is 90, this 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 is 90. Even though the corresponding angles are equal, since the corresponding sides are not in the same ratio, the two figures are not similar to each other. You know that in a square, each of the angle is 90 degrees, right? Similarly, in a rectangle also, each of the angle is 90 degrees. The corresponding angles are equal, but then the ratio of corresponding sides is not same here. Hence, the two figures are not similar to each other. Let us now look at these two quadrilaterals. Do they look similar? No, they don't look similar. The ratio of corresponding sides is same here, but then the corresponding angles are not equal. For angle A, the corresponding angle is angle P. Angle A is 90 degrees, but then angle P, it looks like an acute angle to me. It is less than 90 degrees. So the corresponding angles are not equal here. In the same manner, angle D is 90 degrees here, but the corresponding angle, angle S, it looks like an obtuse angle to me, more than 90 degrees. So obviously the corresponding angles are not equal, and hence the two figures are not similar to each other. Even though the ratio of corresponding sides is same, since the corresponding angles are not equal, the two figures are not similar to each other. You can see that the ratio of corresponding sides is same. How? 3 by 6. That gives me 1 by 2, isn't it? 3 by 6. 3 into 1 is 3, 3 into 2 is 6. So the ratio here is 1:2. The ratio of these two corresponding sides. In the same manner, the ratio of these two corresponding sides is also 1:2. Because 3 by 6, again that gives you 1 by 2, which is 1:2. And again the ratio of these two corresponding sides is also 1:2. Why? Because 3 by 6, that gives you 1 by 2. 1 by 2 is 1:2. 3 by 6, that gives you 1 by 2, which is nothing but 1:2. Even though the ratio of corresponding sides is same, but then since the corresponding angles are not equal, the two figures are not similar to each other. So what do you understand from this? What we understand is both the conditions should meet. Both the conditions should be met. If just one of the condition is meeting, then the two figures are not similar to each other. Both the conditions should be met, meaning two polygons having the same number of sides are similar to each other if the corresponding angles are equal and if the ratio of corresponding sides is same. Now, with this information, I believe we are now in a position to solve the first exercise 6.1. Now in the first exercise 6.1, the first question, it says fill in the blanks using the correct word given in brackets. All the circles are dash. Are all the circles similar or all the circles congruent? See, I would say all the circles are similar to each other. Because obviously this is a circle, that is a circle, they have the same shape, but then they may not have the same size, because one of the circle may have a smaller radius, let us say 3 centimeters, and then the other circle may have a bigger radius, let us say 6 centimeters. So obviously when they have different radii, the size is going to differ. The size is going to differ. They cannot be congruent because the size is different. But then they will be similar because they have the same shape. This is a circle, that also is a circle. So what should be our answer here? Similar. All the circles are similar. In the same manner, all the squares are dash. Are they similar or are they congruent? See, I would say all the squares are similar because obviously they have the same shape. This is a square, that is a square, they have the same shape, so they are similar. They may not have the same size because the side length of the squares may differ. One of the square may have a side length of 5 centimeters, the other square may have a side length of 8 centimeters. So obviously the size differs there. And since the size is different, they are not congruent to each other, isn't it? Because what are congruent figures? Figures which have the same size and the same shape. So so all the squares are similar because two squares, no matter what size they have, they would still have the same shape. So obviously all the squares are similar. Now the third bit, all dashed triangles are similar. I would say all equilateral triangles are similar. What is an equilateral triangle? An equilateral triangle is a triangle in which all the three sides are equal to each other. So I have an equilateral triangle ABC here, in which the sides AB, the side BC and the side AC, they are all equal to each other. And I hope you know this. If you use the angle sum property, you will understand that each of the angle of an equilateral triangle is 60 degrees, isn't it? So I have an equilateral triangle here ABC, in which each of the angle is 60 degrees. And here I have a little bigger equilateral triangle. Obviously, since this is an equilateral triangle, the three sides are equal to each other and each of the angles is equal to 60 degrees. So let us say in this equilateral triangle ABC, each of the equal sides is 3 centimeters, and let us say in this equilateral triangle DEF, each of the equilateral sides is 5 centimeters. Now, if we take the ratio of the corresponding sides, we see that the ratio of the corresponding sides is same. Why? Obviously, if you take the ratio of these two corresponding sides, the ratio is going to be 5 by 3, which is 5:3. The ratio of these two corresponding sides is also 5 by 3, which is 5:3. And the ratio of these two corresponding sides is also 5 by 3, which is nothing but 5:3. So you see that in two equilateral triangles, even though they may have different sizes, but then the corresponding angles are equal and the ratio of the corresponding sides is same. So two equilateral triangles are similar to each other. So all equilateral triangles are similar. And that may not be the case with isosceles triangles. An isosceles triangle is a triangle in which two of the angles are equal. So now let us say I have a triangle ABC in which the two of the equal angles are equal to 30 degrees each, and then I may have a different isosceles triangle in which each of the equal angles are 45 degrees each. In that case, the corresponding angles are not going to be equal, so two isosceles triangle, they may not be similar. Let us discuss question number 4 here. Two polygons of the same number of sides are similar if their corresponding angles are equal and their corresponding sides are proportional. This is something that we went through in the earlier page, right? Two polygons having the same number of sides are similar if the corresponding angles are equal and the ratio of corresponding sides and the corresponding sides are proportional, meaning the ratio of the corresponding sides is same. In question number 2, he's asking us to give two different examples of a pair of similar figures. Similar figures are figures which have the same shape but not necessarily the same size. So I drew two circles here. One of the circle has a radius of 4 centimeters and then the other circle has a radius of 2 centimeters. Obviously, since they have the same shape, because this is a circle and this also is a circle, they have the same shape but not the same size because the radii are different here. And so this is an example of a pair of similar figures. They have the same shape but not the same size. I give you one more example here of a pair of similar figures. Two squares of different side lengths are also similar to each other because obviously they have the same shape. Figure ABC, quadrilateral ABCD is a square in which all the four sides are equal, and then quadrilateral PQRS is also a square in which all the four sides are equal to each other. So obviously two squares having different side lengths are similar to each other. They have the same shape. This is a square and this also is a square, but they don't have the same size. So obviously two squares of different side lengths are similar to each other. In the same way, he's asking us to give examples of a pair of non-similar figures. And that's the reason I drew a circle here and then an equilateral triangle here. A circle and a triangle, they are not similar to each other because they have different shapes. This is a circle, The shape of this one is a circle and the shape of this one is a triangle. They don't have the same shape. So obviously they are non-similar figures. In the same way, I drew a rectangle here, rectangle ABCD, and then I drew a triangle here, triangle DEF. They have different shapes because this is a rectangle and this is a triangle. They have different shapes and so they are non-similar figures. Similar figures are figures which have the same shape but not necessarily the same size. If the figures do not have the same shape, obviously we call such figures as non-similar figures. Now these two figures, they don't have the same shape, so they are an example of non-similar figures. Likewise, these two also, they don't have the same shape, so these are non-similar figures. Question number 3, it says, state whether the following quadrilaterals are similar or not. Can you recall when are the two polygons having the same number of sides similar to each other? Two polygons having the same number of sides are similar to each other if the corresponding angles are equal and if the corresponding sides are in the same ratio, isn't it? Now, let us see if the corresponding angles are equal here. I see that the corresponding angles are not equal here. This one looks like an obtuse angle to me, greater than 90 degrees, but then this one is 90 degrees. So the corresponding angles are not equal. This angle, it looks like acute angle to me, less than 90 degrees, because obviously this one would be 90 degrees. This like this it would be 90 degrees, but then this is less than 90 degrees, acute angle. I hope you understand. This is an acute angle less than 90 degrees, but then this one is 90 degrees. So the corresponding angles are not equal. But the corresponding sides are in the same ratio. I have found out the ratio of the corresponding sides and I see that the ratio of corresponding sides is 2:1 all the time. Even though the ratio of corresponding sides is equal, but since the corresponding angles are not equal, the two quadrilaterals are not similar to each other. 3 by 1.5, that gives you 2 by 1. 2 by 1 is nothing but 2:1, right? 3 by 1.5, that again gives you 2 by 1, which is 2:1. 3 by 1.5, that gives you 2:1 ratio once again. 3 by 1.5, that gives you the ratio 2:1 once again. 1.5 into 1 is 1.5, 1.5 into 2 is 3. So 2 by 1 you can write it as 2:1. The ratio of corresponding sides is same, but then the corresponding angles are not equal, so the two quadrilaterals are not similar to each other. With this, we have completed the first exercise. I look forward to see you all in the next video. In the next video, I will teach you the proof of basic proportionality theorem, and then I will also teach you the proof of the converse of basic proportionality theorem, and we'll do activities related to basic proportionality theorem and the converse of basic proportionality theorem, and hopefully we will solve all the questions from exercise 6.2. I'll see you all in the next video. Have a great day ahead. Until then, goodbye.